Okay, so a snippet from chapter 19, which is about electrochemistry. That is a topic for, that's a topic for, okay, it's working now. That's a topic for Chem 1B, but we got to learn this. So this is a section about balancing redox reactions. We just covered this today, but we'll go over it because it doesn't hurt. Oil rig, oxidation is loss of electrons, reduction is gain of electrons. That's one way to define it. We can also define it as oxidation is an increase in oxidation state. Reduction is a decrease or a reduction in the oxidation state. So if we look at this balanced chemical equation, calcium reacting with water, producing calcium hydroxide and hydrogen gas. We can assign oxidation states. We see the calcium has an oxidation state of 0 here. In water, hydrogen is +1, oxygen is -2. Over here now, the calcium has become the calcium 2+ ion, so its oxidation state is +2, like its charge. In hydroxide ion, oxygen is -2 and hydrogen is +1. And in the hydrogen gas, being an element by itself, is 0. So we see that calcium goes from 0 to +2, an increase in oxidation state. Calcium is being oxidized. And we see that hydrogen goes from +1 here to 0 over there. There's also some +1 hydrogen over here. So not all of the hydrogen's being reduced, but some of it is, and this is the reduction. Okay, so we covered that. Now, what's important in balancing these redox reactions, the ones that are in chapter 4 are more straightforward, but sometimes you can't balance these by inspection. Because in order for this to be balanced, not only does mass have to balance, the number of atoms of each element, but the charge has to balance also. And so a method for balancing redox reactions that do not work balanced by inspection is called the half reaction method. So we break the equation into 2 half reactions, one for the oxidation, one for the reduction. We balance them separately, and then we add them together. It sounds like it's tedious, but the other way is just like a nightmare if you try to balance some of these by inspection. Here's a review of oxidation state since we just covered this today. We shouldn't really need to do this, but there it is. It's the same as what I just covered. And here's our table, FA 765. So here's the half reaction method. We need to identify the substances being oxidized and reduced. That'll probably require looking at oxidation states and assigning oxidation states. But you got to identify what's being oxidized, what's being reduced. We're going to separate the overall reaction into 2 pieces, 2 half reactions. One for the thing being oxidized and one for the thing being reduced. Each of those half reactions then, we are first going to balance with respect to mass. And we want to do it in this order. We want to leave hydrogen and oxygen for the end, if they are there at all. Balance everything but hydrogen and oxygen. Then balance the oxygen by adding water where it's needed. And after that, balance the hydrogen by adding hydrogen ions. After that, we balance each half reaction with respect to charge by adding electrons. We need the charge of everything on the right side to equal the charge of everything on the left side. So then we've got 2 balanced half reactions. To add these together, we need the number of electrons in each of those to be the same. And so we may need to multiply one or both of them by a small whole number to get the same number of electrons. Hopefully this will make a lot more sense when we do an example. Then you add them together, canceling electrons and anything else that can be canceled, and double check that it's balanced. Let's do an example. So here I've got the question. Here we're supposed to balance this, and here is a short version of the steps so that we can refer to these. We're supposed to balance this redox reaction. Now you might look at that and say, well, it's already balanced. 1 aluminum, 1 aluminum, 1 copper, 1 copper. The problem is that on the left side we have a total of positive 2 charge. On the right side we have a total of positive 3 charge. You can't have a charge just appearing out of nowhere. So this is balanced by mass, but not by charge. So we're going to use the half reaction method. So first of all, we're going to assign it to oxidation states. So for the aluminum over here, Al, what's the oxidation state? 0. And for the copper 2 ion, +2. Over here for the aluminum ion, +3. And for copper metal, 0. Okay. With these, the charges in the oxidation states are exactly the same number. So then we need to identify what's being oxidized, what's being reduced. Well, so the aluminum is going from 0 to +3. That's oxidation. The copper is going from +2 to 0. It's going down. That's reduction. Separating these into 2 half reactions, you actually don't even need to recognize which one's being oxidized and which one's being reduced as long as you separate them correctly. So aluminum and aluminum ion obviously have to be together because you can't change aluminum into copper in a reaction, but you can change aluminum into aluminum ion. So one of these reactions will be aluminum, that's the part of it on the left, and that's going to go to Al3+ aqueous. That happens to be the oxidation half reaction because aluminum is being oxidized. The other reaction is the Cu2+ going to Cu. So Cu2+ aqueous going to Cu solid. That's the reduction. So this species was being reduced. So I've got the reactant side on the reactant side and the product side on the product side. Everybody okay with that? Now we need to balance with respect to mass, looking at atoms. Well, these are already balanced, right? 1 aluminum, 1 copper, 1 copper. Then we need to balance with respect to charge. We do that by using electrons. So this one, aluminum going to aluminum +3. This side is 0, this side is +3. We need them to be the same on both sides. We can only add electrons, but you can add them to either side. So I'm going to need to add electrons to the product side. And because I need the charge to be 0 overall, because it is 0 here, I need 3 electrons over there. Everybody okay with that? Now the charge is balanced too. Then I'm going to look at the other half reaction. Here I've got the positive charges on the left and 0 charge on the right. So here I have to add electrons on the left side. I need 2 electrons, 2 negative charges with the +2 charge. That adds up to 0, and a 0 on the right side. We also see here now what's happening with the electrons. So aluminum going to aluminum ion is losing 3 electrons. Oxidation is loss of electrons. The copper 2 ion is gaining electrons. Reduction is gain of electrons. So they're balanced now. Step number 5, we need to make the number of electrons equal. So in the first half reaction I have 3 electrons, in the second reaction I have 2 electrons. I need it to be the same number of electrons. So I have to go for the least common multiple. Least common multiple of 3 and 2 is 6. If I multiply this by 2, I'll get 6. If I multiply that by 3, I'll get 6. To keep it balanced, I have to multiply everything in there by that number. So this one I'm going to do times 2, and this one I'm going to do times 3. So it's going to be 2 aluminums, 2 aluminum ions, and 6 electrons. It is still balanced with respect to mass and charge. The bottom one I'm going to multiply by 3. That'll give me 6 electrons, 3 copper ions, and 3 copper atoms. Still balanced. Okay? Then we add these two half reactions together. It helps if you stack them up so the arrows are lined up. So I'm just going to add these together. So these are all the reactants, and these are all the products. I'm putting them back together again. So I've got 6 electrons plus 3 copper 2 ions plus 2 aluminum atoms. In addition, order doesn't matter. 3 copper atoms, 2 aluminum ions, and 6 electrons. Everybody okay with that? I'm just taking the reactants from both half reactions and putting them together on the reactant side. I'm taking the products of both half reactions and putting them together on the product side. You see the electrons here? I have 6 electrons here, and I have 6 electrons there. They cancel out. You could think of them as spectators. So, because what's happening is they are going from the aluminum to the copper ion, but they're never just out and about by themselves. They get transferred, they get handed off directly, and you don't actually see them. So then this is my balanced chemical equation. Pardon me? It is a lot of work. Oh, I left off the little plus here on my 3 plus. It is a lot of work, especially when you're first learning how to do it. A little practice and it comes easier. Any questions? Yeah.
What if it's a compound?
What if it's a compound? That's an excellent question. Let's look at one that has a compound in it. Right, that's the one we just did. Here's another one. Oh, this one doesn't have a compound yet. We'll get to it. Yeah. This one's a little more complicated. Here we've got hydrogen ion and chromium atoms making hydrogen gas and chromium ions. So if you really hate oxidation states, a lot of times you can kind of skip that part. I shouldn't say that, should I? But, here, the hydrogen ion must be, one of the reactants, and the chromium must be the other reactant for the other half reaction. And then the H2 obviously goes with the H, and the Cr2 plus obviously goes with the Cr. So on some of these, you could skip doing that and be okay, but I'm going to go ahead and do it. So on hydrogen ion, what's the oxidation state? +1. And on chromium atoms, 0. Hydrogen molecules, 0. And chromium 2 plus ions, be +2. So the Cr and the Cr2 plus are part of one half reaction. The H plus and the H2 are part of the other one. So I'm going to have H plus here and H2 here. So I'm going to separate them into half reactions. On the left I've got Cr solid, and on the right I've got Cr2 plus aqueous. I have to balance with respect to mass. Is the first one balanced? No. On the right I have 2 hydrogens, and on the left I only have 1. So I need to put a 2 over here. 2 hydrogen ions are going to make an H2 molecule somehow. The second one, Cr and Cr2 plus, that one's already balanced. So I've got balance with respect to mass. Now I need to balance with respect to charge. Here I've got 2 positive charges on the left and a total of 0 on the right. So how many electrons do I need to add on the left? 2. 2 electrons.
Left side. Like right side.
No? I've got 2 negative charges and 2 positive charges. That adds up to 0. And so then, oh, the chromium. On the chromium, we need to do the electrons on the other side, on the right side. So here I'm adding 2 electrons over here to, balance out these plus 2 charge. So this adds up to 0 charge, this adds up to 0 charge. The next thing is to make sure the number of electrons are the same. Here I've got 2 electrons and 2 electrons. I don't have to multiply. So add these together. I've got the same number of electrons. Let's just cross those off right now. And then I'm going to copy down what's left. 2H plus aqueous plus Cr solid goes to H2 gas plus Cr2 plus. So that one's a little simpler. Always double check at the end, make sure the charges and the masses balance. Step 7, verify. Any questions? That one was actually simpler than the first one. Okay, here's one that's a little more complicated. Here I've got iron, 2 plus going to 3 plus, okay. Here I have the permanganate ion going to the manganese 2 ion. You look at this equation, how would you balance that without doing half reactions? There's oxygen here, and there's no oxygen over there. What the heck? It's going to involve water. Yeah, because water participates in some of these reactions. So let's look at this and see what's happening. Practice our oxidation states. Fe2 plus 2. Skip permanganate, that looks icky. Fe3 plus 3. Mn2 plus 2. Okay, now we have to get back to the icky one. So this one, we got oxygen here in here, we've got manganese in here. This is a polyatomic ion. We can't figure out the charge on manganese just based on the oxygen. It's not an ionic compound. So we do Fe765. Oxygen gets what it wants. Oxygen wants to be -2. There are 4 oxygens. So 4 times the -2 is a total of -8 oxidation state from the oxygen. And overall, we have a -1 charge. So manganese will be what? +7. So 7 and -8 gives me -1. Write it out if you need to, because it is easy to come up with 9 instead of 7, but it's not right. Okay, so we've got iron being oxidized, and we've got manganese being reduced. What's happening to the oxygen? Probably nothing. So we're going to split this into 2 half reactions. So we've got Fe2 plus on the left and Fe3 plus on the right. For the second reaction, we have MnO4 minus on the left. Oh, that's aqueous. And Mn2 plus on the right. Balance for mass. Well, the first one's already balanced for mass. The second one is not. The manganese is fine, but we've got 4 oxygens here and no oxygen on the other side. So the rule says balance the things besides hydrogen and oxygen first, balance the oxygens by adding water, and then take care of the hydrogens. So to get four oxygen atoms on the right side, I'm going to have to add 4 water molecules. Right? Because that'll give me 4 oxygens. Now that introduces hydrogen in here, so we have to take care of that. But we're going to take care of that by adding H+. So I have 8 hydrogens here, so I'm going to add 8 hydrogen ions on the left side. And that's how I get it to balance for mass, the atoms. The next thing is to balance the charges. So here I've got +2 and +3. They're not going to be 0 on each side. I just need to make them the same. So if I add 1 electron to the product side, then I've got my +3 and -1 adds up to +2, and it's balanced. Down here we got a lot more going on. Here I have +8 and a -1. So my total over there is +7. And over here I have a total of +2. So I'm going to have to add electrons over here to bring this +7 down to equal +2. So I'm going to have to add 5 electrons. Everybody okay? What do we do next? Can we just add these together? No. Electrons. So this one has 5 electrons. This one only has 1 electron. These half reactions are happening together. The number of electrons given off by this one has to equal the number taken up by this one. So we have 5 and we have 1. We can just multiply the top one by 5 and get it to be okay. So 5 iron 2 makes 5 iron 3 plus 5 electrons. Now when we add these together, the 5 electrons on each side are going to cancel each other out. So we add these together, cancel those guys. So I end up with 5 Fe 2 plus aqueous plus 8 hydrogen ions plus permanganate ion forming 5 iron 3 ions and manganese 2 and 4 water molecules. You should double check that. If we've done everything carefully, it should be fine. Any questions? I'll take that as a no. Let's do another one. Practice makes perfect. Okay, balance this one. Well, I'm going to skip the whole oxidation state one on this, just because I feel like it. Obviously, the copper and the copper ion have to be together, and then this guy and that guy have to be together. Do we really need to know what's oxidized or reduced? We actually don't. We can just write the half reactions. So solid copper is going to go to copper 2 plus ion. And nitrate ion is going to go to nitrogen dioxide gas. The first equation is balanced for mass, so we don't have to mess around with that one. This one is not. The nitrogens are balanced, the oxygens are not. I have 3 oxygens here, I have 2 there. I balance the oxygen by adding water. If I add 1 water molecule over here, now I've got 2 plus 1 is 3 oxygens and 3 oxygens. So now I've introduced hydrogen in here, so I have to take care of the hydrogen. You balance the hydrogen by adding H+. So if I put 2 hydrogen ions over here, that'll balance the 2 hydrogens on the other side. Balance for mass. Then balance for charge. So here I've got 0 on this side, I've got +2 on that side. So I need to add 2 electrons. Down here, I've got, nothing has charges over there, so that's 0. I've got +2 and -1. So those add together to be +1. So I only need 1 electron. Charges are balanced. Now we need to make sure that we have the same number of electrons being transferred. This one, we've got 2 electrons being lost. This one, we have 1 electron being gained. It has to be 2. We make it 2 by multiplying all the coefficients by 2. So I'm going to make that 2 electrons, 4 hydrogen ions, 2 nitrate ions, 2 nitrogen dioxide molecules, and 2 water molecules. Still balanced for charge, still balanced for mass. Add them together. So the 2 electrons go away. And I copy down what's left. So copper, solid, plus, 2 nitrates, aqueous, and can't forget the 4 hydrogen ions. That makes Cu2+, aqueous, plus 2 NO2 gas, plus 2 H2O liquid. Questions? A good way to get this in your head is to pull up the YouTube video to where it shows the problem, pause it, do it yourself. If you get stuck, forward through until you're like, oh, okay, and then stop it again, until you can do it yourself. If you do it several times, you remember the order of what you have to do. So all of those half reactions were balanced in acidic solution. So they all said in acidic solution. That's kind of normal. What if the half reaction is occurring in a basic solution? A basic solution has an excess of hydroxide ions. An acidic solution has an excess of hydrogen ions. So we follow the same procedure, but we have to add 1 step. When we're balancing by mass, you're going to balance all the elements other than hydrogen and oxygen, balance oxygen by adding H2O, balance hydrogen by adding H+, and then here's the extra step. Neutralize the hydrogen ions by adding enough hydroxide ions to neutralize each of them. Add the same number of hydroxide ions to each side of the equation. If you have 2 hydrogen ions on one side of the equation, then you add 2 hydroxide ions to both sides. And H+ and OH- becomes water. So we're going to balance this redox reaction in basic solution. Starts out the same. So iodide and iodine are going to be together. Permanganate ion and manganese 2 oxide are going to be together. So I minus aqueous going to I2 aqueous. MnO4 minus aqueous. Going to MnO2 aqueous. Splitting into 2 half reactions. That's a mess. I'm going to fix this. That's better. Balance for mass. So in the first half reaction, I have 1 I and 2 I's. So I need to put a 2 over here, so I have 2 I's on both sides. In the bottom, the manganese is fine, Mn, Mn. Oxygens, I have 4 oxygens here, and I have 2 over here. So I need to add 2 more to the right side. I do that by adding H2O. I need 2 of them. Now I have 4 oxygens on this side and 4 oxygens on that side. To balance the hydrogens, I've got 4 hydrogens over here now. I need to add 4 hydrogen ions over here. It is now balanced with respect to mass, but it's basic solution. So I need to neutralize these hydrogen ions. There's 4 hydrogen ions here, so I'm going to add 4 hydroxide ions to both sides. If I have 4 hydroxides and 4 hydrogen ions, what does that make?
H2O.
Makes H2O. How many?
8.
No. I've got 8, 3, and 2. 9? 4! Makes 4. H plus OH minus makes H2O. We're all getting a little punchy, aren't we? There's a reason we don't usually have this many hours of lecture. Okay, so that makes 4 water molecules because each hydrogen and hydroxide pair makes 1 water molecule. So I'm going to simplify that. So that makes 4 water molecules. So instead of that big old mess, I'm going to write 4 H2O. Okay? Now, I've got 2 H2Os over there, and I've got 4 over there. What's up with that? So I just basically have 2 water molecules that are spectators. So I could simplify that out if I want. Or I could leave it alone and take care of it later. I'd rather take care of it now since I'm talking about it. If I have 4 water molecules over here and 2 over there, it'll still be balanced if I have 2 here and none there. You okay with that? So if I get rid of these 2 and knock this down to 2, it's still balanced, right? Oh, the looks. What the heck? Okay, I won't do that. We'll leave it alone. We'll fix it later. Now I have to balance for charge, right? So this one I have 2 negative charges on this side and none over here, so I need to add 2 electrons to the right side. So charges add up. Hopefully the wicked looks will go away. Here I've got -1 here and -4 over here. So I have to add 3 electrons here. Are you okay with that? then we have to make sure the number of electrons is equal, and it isn't. So I need to multiply this top reaction by 3 so that I can make this 6 electrons. Oops, that's not what I wanted. So multiplying by 3, I get 6I minus and 3I2 and 6 electrons. The bottom, to get 6 electrons, I'm going to multiply by 2. Got to multiply everything by 2. So that gives me 4 times 2 is 8. Multiplying by 2. I'm multiplying by 2. I'm multiplying by 2. I'm multiplying by 2. So that's 4. I forget sometimes. Multiplying by 2, 8. Isn't this fun? That's awesome. Okay, so we need to add these together. Awesome. It's not going to fit on one line. So the electrons cancel out, right? Are we okay with that? So 4, that's not a 4, that's an 8. How do I write 8 and say 4? 8 H2O plus 6 I minus aqueous plus 2 MnO4 minus aqueous. Did I get everybody? Yeah, got everybody. And then I'm going to do 3 I2 minus, no, just I2, sorry, aqueous. And 2 MnO2 aqueous. And then I've got 8 hydroxide ions. Ooh, I'm going to make it on one line. And 4 water molecules. It's a pain, but you could go through that and check and make sure, yeah, it's balanced. I've got 8 water molecules over here, and I've got 4 water molecules over here. That's kind of sloppy. So what if I subtract 4 water molecules from each side? Is that going to affect the balance? No, because I'm doing the same thing to both sides. That's a crappy O. So 8 water molecules minus 4 water molecules is just 4 water molecules, right? And over here, 4 minus 4 is 0. So I'm going to get rid of those guys. That's why I wrote it on the end. And over here, I'm going to change this 8 to a 4 and get rid of my scribbles. Okay. Any questions? Aren't you glad you stayed? Sorry. This is one of those things, it's like, oh, I hate to do this to them. It's hard. I get it. Life is hard. Let's balance this one. Come on, it'll be fun. Said no one ever. Okay. We're not even giving you the really ugly ones. So this doesn't work to write with the eraser. Those two go together. Do you know why? They both have chlorine in them. And these two are going to go together because they both have the chromium in them. Hydrogens and oxygens, they're going to just like kind of come and go. We don't need to worry about those at all at this point. You got to get the other elements in their correct half reactions. Okay. ClO minus, aqueous on that side, and Cl minus, aqueous on this side. CrOH4 minus. That's a weird ion that we don't learn how to name in Chem 1A. And then we've got chromate on that side. First balance for mass. My chlorines are okay, but I have an oxygen here. I balance the oxygens by adding water. So I'm going to add water on that side so that I get the correct number of hydrogens. Then I have to balance, correct number of oxygens. Then I have to balance the hydrogens. I do that by adding H+. So I need 2 H pluses over there. But this is in basic solution. So I need to get rid of these 2 H pluses. I do that by adding 2 hydroxides. Because 2 hydroxide ions and 2 hydrogen ions make how many water molecules?
4.
That's the answer to the other one. They make 2. Thank you. So I've got two OHs over here. It's details. It's just tons of details, right? So these guys make 2 water molecules. So that's, I'm going to write those. So would you be okay with subtracting a water molecule from each side? Would you be okay with that? Because if I subtract a water molecule from each side, then I get rid of that one over there. So I'm going to get rid of one of those, and then I'm going to get rid of one of these. Yes?
Why didn't we add a which on the left side? On the first one? Oh, I'm lost.
Why is everybody laughing?
I got 3 hours of sleep.
You got 3 hours of sleep. That is an excellent reason to be laughing hysterically, and then one person starts laughing, and then everybody starts laughing. But we're having fun. No. We're laughing, but we're not having fun. Okay, so the question is, why did I put hydroxide over there?
Yeah.
Okay, when I first balanced it, I had hydrogen ions on this side. This is in basic solution, so I need to get rid of them. The way you get rid of them is by adding hydroxide ions. This, I have another name for this. This is a soda, which isn't as good, but Rockstars are better. It's liquid nap. Yep. Sleep in a can. It's good stuff.
I don't get why we keep trying to take away water molecules.
Why do I keep trying to take away water
Because
molecules?
then we have like one extra over here and then like none over here, so then it's like not balanced because there's one here.
But it's still balanced because I had 2 over here. I had 2 water molecules here and I had 1 there. And so I just took away the extra one that wasn't doing anything.
So like on the test, we just take those away?
Yeah, you can just take those away. I can see that this is bothering us, so I'm going to put them back. Oops, I didn't want to do that.
So is it just like in math when you simplify, say like
It's just like in math when you're simplifying. Yes. So let's switch to math for a minute. If I have 2A plus B equals C plus A, can I get rid of some of those A's?
Yes.
Yeah. I can subtract an A from both sides. This one goes away, and then I've got 1 left over here. That's what I'm doing. Is that better? Okay, so I can do it? Okay. So I'm gonna get rid of that guy. And now I just have 1 over here. Okay, so that one's balanced for mass. And we can check it. Here there's 2 hydrogens, and over there I got 2 hydrogens. Here I've got 1 oxygen there and 1 there. That's 2 oxygens, and here I got 2 oxygens. 1 chlorine and 1 chlorine. The mass is good. Do the other one for mass. I have 1 chromium and 1 chromium. I have 4 oxygens and 4 oxygens. Nice. But then I got these 4 hydrogens. So I need to put 4 hydrogens over here. And I put those in as 4 hydrogen ions. So I put the 4 hydrogen ions over here, but in basic solution we don't have hydrogen ions, we have hydroxide ions. So I put 4 hydroxide ions over here and 4 hydroxide ions over here. 4 hydrogen ions plus 4 hydroxide ions makes how many water molecules?
4.
4, yes.
I was like, I'm not gonna answer this.
I'm not going to answer this one. You know, it's okay to make mistakes. Mistakes happen all the time. One of the benefits of getting older is that you just really don't care very much what people think of you. It's very freeing, you know, you just be yourself and to heck with everybody else. Okay. So that one's okay now, right? Mass. Now we have to balance charges. So we've got a total of -1 here and -3 on that side. So I'm going to add 2 electrons over here. So I've got a total of -3 charge and -3 charge over here. Everybody okay with that? Down here I have -4 and -1, so -5. And over here I've got -2. So I have to throw in 3 electrons to balance the charge. Okay? Again with the 2 and the 3 business. I got 2 in one and 3 in the other. I got to make them both 6. So I'm getting tired of green. I'm going to go with red. Multiply by 2 to get 6. Multiply by 2 gives me 8. Multiply by 2, multiply by 2, multiply by 2. So this one was times 2. This one's times 3. So this becomes 6, and 3, and 3, and 3, and 6. Yeah. Okay? Now we add them together. Electrons go bye-bye. Bye-bye, electrons. Copy down what's left. Do you want to subtract some water molecules? They laugh. That's the sound of people about to have their brains explode. I've got 3 water molecules that are going to end up on the left side of my finished equation, and I have 8 on the right side. I could take care of those now, or I can take care of them later. I am sensing that you would prefer me to take care of them later, so I'm fine with that. So here's 3 H2Os, 3 ClO minus, and then I've got 8 OH minus. No, I didn't. Oh, fine, whatever. 8 OH minus and 2 CrOH 4 minus aqueous 3 Cl minus and 6 OH minus That's not going to fit. 2 CrO4, 2 minus, and 8 H2O, good grief, liquid. What a mess, right? It's balanced. Is it the best? No. I've got water molecules on both sides. So this is like, I've got 3y plus 8x is equal to 6x plus, wait a minute. I didn't want to be way over there in the corner. I was trying to be in the middle. I zoom in and I get lost. I've got 3 water molecules, and I have 8, oh God, no, that looks like ounces. Oh, let's go with X. 8 hydroxides on that side, and over here I've got 6 hydroxides, so 6X, and I have 8 water molecules. So could I simplify this mathematical equation?
Yes.
Yeah. I could subtract 6 x's from both sides, right? Then the x's over here would disappear and I'd have 2 x's. I can do the same thing with these hydroxide ions. I have 8 hydroxide ions here, I have 6 hydroxide ions there. I could pull 6 of them off both sides and it's still balanced. So I'm going to do that. So this 8 becomes a 2. And subtracting 6 hydroxides from the other side, they all go away. (3y plus 8y equals 8y. Well, if I subtract 3y from both sides, I have 5 y's on this side and none on that side. I'm just simplifying. If I subtract 3 water molecules from this side and 3 water molecules from that side, then I end up with 5 water molecules over here and none on the other side. That's just cleaning things up. Now, if I wasn't just really sick of doing this, I would rewrite that nicely, but we can see what it is. This is one that would be pretty tough to balance without using the half reaction method. What's especially disturbing is that this side has hydrogens and that side doesn't have any hydrogens, and how the heck could that happen? It's because this is a net ionic equation. It's just showing the things that are involved in change in chemical reaction.